the Sumerians used a system of mathematics which was the sexagesimal system, which had been prior to this the base 6 system. The numbers initially were 6, 5, 4, 3, and then they decided for more accuracy in their measures, it was good to decimalize it. So it became 60, 50, 40 and 30. Now, the central note would have been 60, which was the number by which the top god, Anu, was named. Anu was the god 60 and the god of 1, because of course in sexagesimal mathematics 60 equals to 1, because when you arrive at 60, the 60 becomes the 1 and so forth. The god, which was the god Ea, which is most important, is the god of 40. And this 40 indicates that, of course, if you got 60, 50, which is the god Sin, you have this is the ratio of a minor third. 50 to 40, this is a major third. So therefore, you have 2/3 bringing to a fifth, and the ratio of Ea to 30 is a fourth. So therefore, the cosmology of the gods is present in the notes, and they define the structure, the fundamental structure of the scale. Because once you have a fourth and you've got a fifth, you subtract the fourth from the fifth and you've got the tone. When you've got a third, a minor third, and you have its reciprocal, it becomes a major 6, and a major third becomes a minor 6. So the ratios 60, 50, 40 and 30 contain all the essential numbers to create a sexagesimal system of music, and this was known about 5,000 years ago. Well, this instrument is as you can see, the replication of the lyre we have at the British Museum in room G56. Now, this instrument was unearthed by, not this one, the one in G6, was unearthed by Woolley in the winter of 1929. And for me, it constituted the best preserved item because it was covered in silver, and although the silver had been crushed flat in the tombs, the outlines were sufficient for making proper reconstructions. Then the silver lyre was transported to the British Museum after it had been covered with a layer of wax so that it could be lifted properly out of the ground. At the museum, the major task was to then melt the wax in order to reveal the silver, which had corroded enormously. Then in 49, in the summer of 49, an attempt was made at displaying to the public. And after the uprights had been filled with more wax, the instrument was standing up on a pedestal. And there was a very, very heated summer of 49, and one day the wax simply melted and the instrument collapsed in front of the public being there looking at it. So after it collapsed in 49, the instrument was taken off public display, and it took ages. It took until 1969 before the instrument could be reconstructed. But then what happened? It was the late 60s, and the principle of conservation of items at the museum was to make them look very much like they were in their lifetime. And this was to the detriment of organology, which was a science nobody had heard at the time. So a lot of the essential bits were destroyed and will never be recovered. However, the documentation at the museum was sufficiently important for me to make serious researches with regard to proper organological reconstruction. So this is what happened. We first discovered that the soundboard had been made of silver, and it was not simply silver which covered a soundboard. The soundboard indeed was silver, and how do we know this? It's because there was only a small amount of dust between the two parts of the soundboard, and therefore we are absolutely certain that the silver was not simply glued to a wooden basis. Now, we have here the soundboard, we have here the uprights, this is the yoke, these are the tuning levers, the strings, of course, and the bridge. Now, we're absolutely certain that this was the length of the strings, the reason being that the instrument was flat on its side in the tomb and nothing had been disturbed. We could even find traces of the string on the ground where it had been resting. As a matter of fact, the instrument was resting on the side of the bridge, and this was very useful because it allowed the strings to leave their impression onto the silver plate. So we knew exactly what was the fan angle, therefore what would have been the length of the strings. They average about 80 centimeters, with the longest being about 83 centimeters and the shortest about 72. This was important as it helped us to define what would have been the tension and the mass of each, taking into account that mostly these would have been guts from pigs which had been twisted raw and then allowed to dry. There was another important thing to discover, is that the tuning levers that we have at the museum are pierced in two places, and I was always wondering why they had been, and the answer is simple. Whereas in the Ethiopian Bagana and early lyre types of Africa, the tuning is mainly done by rotating the levers around the yoke. The Sumerians had progressed in this, that the levers simply had to be turned around like ordinary tuning pegs. And this was indeed an innovation in the history of making instruments.